Nice. How do we simplify limits, right? So before I show you how to simplify limits, we have to know all the theorems here. All right. So we have to know all these rules here that would allow us to simplify a limit, right? So you can copy that one time. Right, because we're going to use these rules here in order for us to simplify, right? Right? While you're writing, right? Look at the first rule. What they're doing in that first rule then? Huh? In the first rule, they're multiplying and show. What does that say? Here's what it's saying, right? It says that we can take the k and put the k on the outside. And you'll get k by the limit of f of x, which is capital F. Say again, kf. See that? Yeah? See that, Jacob? Right? So whenever constant, you can pull the constant outside. What is the next rule saying, Darian? Darian? Oh, you're gonna get into Darian. Esther, what does rule rule 2 say? Right? But so here what rule 2 saying, right? Here's what rule 2 is saying. If you have a product, you can write it like this: the limits. Yeah, very good. The limit that x approaches a of f of x by the limit that x approaches a of g of x. So if I have a product, I can find the limit of each one. That's okay? That's okay? The third one, self-explanatory. They'll say the fourth one, okay, the fourth one fit. The fourth is just like 2, right? You can divide limit f of x divided by limit g of x. Right? So the fourth one is the same as the second one. Right. What's the third one, Olin? The fifth one. That's the most important rule. Really important, right? I want to show you how to use that rule because we're going to simplify with a square root. And I want you to identify that this rule is what we use it. Well, 5 simplification. The other rules are factorization and multiplication. I cannot split them up. There's no to split them up. Huh? Not really. Rule 1, k is constant. So you can put the constant outside. Yeah, the cutoff, yeah. 2 functions. Right. What you see earlier? What you saying? Watch what you can do with this rule, right? Let's say I give you the limit of x approaches a of f of x squared. What you can do now is you can find the limit of f of x and then square it. Right? Or if I give you something like this, the limit of x approaches, sorry. I'm going to write a little bit neater. X approaches 2 of x minus 3 square root of all of that. Right? In order for us to simplify that, what we could do, what this rule number 5 saying is that I could take the square root and pull the square root outside here. That's okay? Right? And that's very useful when you're simplifying limit with roots in it. Okay? So you can actually pull the square root on the outside, find the limit inside here, and then square root it. So it makes it much easier. Okay? Kisha? Right? So those are your first 5 rules. Next, whenever we simplify limits and we end up with something called an indeterminate. Anybody remember what indeterminate? Indeterminate is like when we have something over 0 or infinity over infinity or something over, sorry. When you end up with something looking like that, right? If you're ending up with infinity, that's said to be indeterminate. Okay? And there are 3 ways that, there are 2 ways that I can simplify it that are allowed on the syllabus. And the third way is L'Hopital. It allows you to check the answer, right? You cannot use that as a valid solution, right? But you can check it. Okay? So we factorize. If that doesn't work, we divide by the highest power of x. Right? At this level, either one should work. And the answer you get, you can check it back using L'Hopital, right? So L'Hopital is a check. All right, let's do a couple examples. I still have 2 more rules to show you, right? For those who did it already, what's the rules? Special limit. Special limit. That's the trick, very good. 1 minus. All right. Right, we are going to do a few examples, but what is one here, right? Excuse me, Daria. If you have to PC, you can help me, okay? Yeah. Help me out here now, please. Look at the first example in Daria. How are we going to simplify that then? Right. So you're going to factorize the, right? But why are we doing that? There's a reason we're doing that, right? Plug in 2. Sorry, minus 2. What you'll get? Right? If I plug in minus 2 underneath, I will end up with minus 2 squared plus 2 by minus 2 all over minus 2 plus 2. So I will end up with 0 and 0. That is indeterminate. Because it's indeterminate, I have to use the rules on top. Right? The first rule you're using is what finish. What the first technique is used? Factorization, right? So as Darian said, you can factor the x. And what happened to the x? The x plus 2 will cancel, and you'll end up with x. Then you plug in your minus 2, and the answer is minus 2. That's okay? Huh? If it's indeterminate, you have to try one of technical simplify. Plugging in. So the first thing you do is plug in the value. And if you end up with something indeterminate, then you have to factorize it. That over divide by always in that order. Yeah, that's only 2 ways around, right? Okay. Watch up here. I'm going to show you L'Hopital. Right? How does L'Hopital work? So you differentiate top and you differentiate bottom. What's the differential of x squared? 2x, right? What's the differential of 2? 2 all over 1. Right? The differential of x plus 2 is 1. Plug in minus 2. Plug in minus 2 and you will get minus 2. Right? So by using L'Hopital, you're still getting the same answer, right? But please remember L'Hopital is a check. Copy it up. Let's go again. Online, any questions? Jesse, are you okay online? Yes, Kelsey, okay, nice. Jacob, help me with this one here now. He didn't take it up. No longer leave that up. Let's come Victoria and finish week 9 next one. I can change it now. Okay, Darius. I'll return you, Darius. How we count this? We have no current. Okay, almost income. Yes, boy, and the man complete. This is. Yes, boy, and the man didn't remember that. Ready to move on. All your diagram ready to move on. Right. So we have a slight problem here. If I were to plug in infinity here, what would happen? What's the limit? Until end up with infinity over infinity. Yeah? Which is indeterminate, right? Right. Try to factorize this one. Does it simplify out? Try to factorize this one out. Let's see what we'll get, right? We'll get 3x over x minus 2, x plus 2. If I plug in infinity, has it been simplified? No. I'm still getting the same thing. So therefore, we have to go to dividing by the highest power of x. Right? Kisha, what's the highest power of x? X squared, right? So we're going to divide by the term with the highest power of x. So we're going to divide each one by x squared, and you will end up with this here, right? Divide this by x squared, this by x squared, this by x squared. And you end up with 3 over x, 1 minus 4 on x squared. When you plug in infinity, you're going to get something looking nice like this, right? 0 over 1, which is 0. Question, is this indeterminate phase? Is 0 over 1 indeterminate? No, because the answer is 0. Very good, Pete. Very, very good. Right, copy it up. So again, you factorize. If factorization doesn't work, you long divide. So you divide by the highest power of n. Question. Anybody remember how to factorize a cubed minus b cubed? Yes. Go ahead.
X squared.
Wrong.
Is e minus d, and it is e squared minus. Yeah, is squared plus ab. Yes, it is squared plus ab plus b squared.
Right. So remember for homework, I asked you to revise how to expand a cubed minus b cubed, right? And a cubed plus b cubed. Okay.
You didn't know that, Jared.
Right, let's go again. Ready? Right, next one. Diversification.
Yes, we can change.
Thank you, Dario. All right. Try number 1 and 2. If you can do number 3, that'll be good. But try number 1 and 2. I'll come in on the board to do it, right? If you can do 3, go right ahead. No, do number 1 and 2. If you can do 3, go right ahead. You want that?
Same number.
All that's part of it. Right? If you want, you can use the hospital to check your answer, right? Right, all right. Jabin of 5 weeks. Jabin of 5 weeks. Nowhere, Jabin. That's the answer. Nowhere. Oh, yeah, move it out.
Yes, Lord. Yes.
Right, all you have to show it indeterminate before you do anything. Huh? So you have to tell them, just put it on top. Put it on top. All the questions that you will get will be an indeterminate, but you have to show them that, right? Yeah, look up people after it. Until you simplify it. Because the limited one, right? On the first one worked out? Yeah, probably an error in the first one, sorry. Yeah, so it's so the first one's supposed to be no, I think that type it out wrong, sorry. Right? Ignore the first one. I think I made a typo in the first one. But I did it. Sorry about that. Right? I think I typed the wrong thing. Yeah,
Much mistakes, no.
that's one so far. Darren. That's one. Okay, two. I apologize. And if you want to do number one, you can pass square by the two as well. Right? So you can use two x squared minus one on the two. Right? What you all do for number, which technique for number two? Factorization, right? Once they get Jacob? Once they get for number two. Huh? Okay, well, fix number one. Put two x squared as number one. Right, for those who did number one, just squeeze in a little square above the x. I think it's chop out in the handle, because it's kind of old handle. Right, do over number one, right? Number one is two x squared underneath. Any answers to number three yet? All right, nice. I'm gonna do them just now. All right, ready? Let's do number one. I'm doing number one and two, right? Right, so for number one, I'm gonna divide by the highest power. Right? When you divide by the highest power, the x squared cancel. And then you plug in x to infinity, so you'll get 3 plus 1 on infinity, 2 minus 1 on infinity. 3 plus 0, 2 minus 0, so that's 3 and 2. 1.5. Are you okay with that? Yeah. Number two, we factorize it, right? So if I factorize on top, I'll get x minus 2, x plus 2. And then underneath we can factor 2x, x minus 2. The x minus 2 will cancel, and you will get the limits as x approaches 2 of x plus 2 over 2x. Then plug in x and 2. Right, so I'll get 4 and 4, which is 1. You okay with that?
Wait, so you just now. Oh, no.
Right, number 2 is 1, number 1 is 1.5. Or separate further. Right, number 1 was 1.5 and number 2 was 1. Try number 3, online message, what do you think you got for number 3? Message your answers for number 3. What you get for number 3? Come on, board, Jacob. Oh yeah, for number 3.
Yeah, but you so like after a certain amount of time, I still pick up on my beat. But while you put it on that path, you might everything. No, I mean, yeah. No, but when you so I'm very
Alright, what y'all got? 8. Very good. Right, so if I take the first statement, right, I can write the first statement like this. Right, using the limit rule, I can use the first statement like this. The limit of x approaches 3 of 2x is 8. Right? I can't simplify this here. So I'll get the limit of f of x as x approaches 3. But I can simplify this and I'll get 2 by 3 is 6. So when I move it across, I'll get the limits of f of x as x approaches 3 is equal to I'll get the limits as x approaches 3 of f of x is 8 minus 6, which is 2. So now I can come here and expose the 4 on the outside. So I'll get 4 by the limit of f of x. So I'll get 4 by 2, which is 8. That's an 8. Are you gonna follow what went on?
Yes.
You sure? Right, so you can actually plug in the 3 and you'll get 2 by 3 is 6 and so on. All right, last 2 rules and then we go into past papers. Somebody write it? That's not Kesha Bracken. And three. Right, last one. Right. Here we have the last set of rules that we need to learn, right? These are called special limits. Right? So I don't know if you're those are doing physics, right? When you did the proof in the experiment, anything like that? No? I know what. Excuse me. Anyway, it don't matter, right? When theta is small, when x is small or theta is small, sine x on x is equal to 1. All right? So if you go to the calculator, right? Go to your calculator. Go take calculator and find sine of a real small value. Let's say 0.000001 and divide it by 0.00001. Put 1 by 10 to the minus 12. Sine 1 by 10 to the minus 12 all over 1 by 10 to the minus 12. And you will see that the value is kind of close to 1. See that? Value kind of close to 1. Yeah? Where you got it? By 10 to the 1. No, it's sine.
Oh, 0.017.
Or the placing value. It's sine of the value divided by the value. Yeah, sine of the value divided by the value. Oh, no, it didn't. Alright, anyway, take it like that. Take it on the value being close to 1. What you got? But what it's saying is when x is small, x close to 0, that's what it's happening. Alright, so there you have 4 rules to learn. Tan x on x is the same thing. But take a look at plus. Yeah, sure. Yeah. Take a look at plus. Right? Cos x minus 1 on x is equal to 0. Not cos x on x. Don't make that mistake, right? So those are the 4 that you have to learn. Well, 5 you have to learn. Right? Once you see sin x on x, that value will always be 1. After 5, no 4. All right, let's start. What are you? What do you write it? All right, so what we see? All right, watch here. Everybody watch here. Watch here, earlier. So in order to simplify these, right, we have to use the rules that I just gave you. So this rule here, in order for us to be able to use the rule sin x on x is 1, we have to make sure that this value and this value is the same. That's okay? So right now, I'm missing a what? A 4. So how do I bring in a 4 then in this case? To bring in a 4 in this case, what you could do is you could multiply the top by 4 and the bottom by 4. Correct? 4 and 4 is 1, right? So it wouldn't change it, right? So I could take this 4 and bring the 4 here. What do I do with this 4? What do I do with this 4 here? Right, multiply by sine, not in here. You can't do the angles. I said put the 4 here. So you get 4 sine 4x, right? What can I do with this 4 here? Pull the 4 on the outside. So I'll get the 4, the limit as x approaches 0 of sine 4x on 4x. What this is here? This here is what? I don't know why I write it like that. What this is here? This value is 1. So it's 4 by 1. So the answer is 4. Right? Your objective is just to make sure that these two things here are the same, right? What is that? This here is the rule I gave you. Right? Ignore the rule I gave you. Sine u on u is always going to be 1 as x approaches 0. Right? So always make sure that this and this is the same. It don't have to be x. It could be 10x and 10x. But these two are to be the same, right? Right. Watch here. Go right here. How are we doing this one here? Most of you know the answer. What's the answer? Right, just watch we know what the answer is, right? But we need to find a way for us to be able to to work it out, right? So watch this here. What here's do no, you don't cancel off the signs. What here's do is this here means division, right? So if you go back to your limit rule, rule number 5, I think, we could break it up like this. I'm giving you all the steps, right? Are you okay with that? These two are the same thing. In order for me to get this rule as 1, what do I need underneath here? A 5x, right? So can I multiply by 5x on 5x? Correct? And what can I do here? Multiply by 3x on 3x. Watch out what happened, right? I'll get the limits again. This is 1, so I'm not changing this. This is 1, so I'm not changing this. So I'll get the limits as x approaches 0 of sine 5x all over 5x, right? Multiplied by 5x divided by the limits as x approaches 0 of sine 3x on 3x multiplied by 3x. That's okay? And this is multiplied. So can I write it like this? The limit as x approaches 0, sine 5x on 5x by the limits as x approaches 0 of 5x. Here I'm doing the same thing. The limit as x approaches 0 of sine 3x on 3x by the limit as x approaches 0 of 3x. What this is here? What this is here? So what we end up with? The limit as x approaches 0 of 5x over the limit as x approaches 0 of 3x. Right? Can I plug out the 5 and 3? Yeah? Can I plug out the 5 here? Can I plug out 3 here? What this is? This will cancel to give you 1, right? So you will end up with 5 over 3. That's okay? Please learn to do all these steps. I know you all can watch it here and figure it out, but you have to give them all these steps. Okay? Right? So all I did is I used the division rule, then I multiply by 5x and 3x. Okay? If you want, there's a next way you can write it as well. If you want, right here, you can multiply by 5x on 5x, multiply by 3x on 3x. But please write limit of this and limit of this. Separate the limit, right? Put it here and here, and then simplify it out. Right? Don't just magically bring in the 5x and bring in the 3x, right? Try number 3 here when you finish, please. No, you're not evaluating. So you're just canceling, no, because they both are the same. Because you end up with 1, 0, and 0. So that's why I need to try that. But yes, it's like a simplified class. Huh? Yeah. Right, so this will cancel away. Now done. Oh, yeah. Ready here?
Yes.
One cell again. One cell again, Selena. 4 and 3, right? So by watching it, you know what the answer will look like, right? So again, we're doing the same thing again, right? Let me see if I can write it out like that method there for you, right? So again, the limit as x approaches 0 of tan 4x over the limit as x approaches 0 of tan 3x. Here, you're multiplying by 4x on 4x. Here you're multiplying by 3x on 3x. Right? What you could do here is you could bring in the 4x here, bring in the 3x here. All over the limit of x approaches 0 of tan 3x on 3x. You have a 4x on the outside here divided by the 3x. This x will cancel, and this will give you 1, this will give you 1. So you'll get 4 and 3. So that can work as well, right? This value here is 1, this value here is 1. Okay. Right, so the answer is 4 and 3. Right? Either one you want, right? You can break it down the long way, or you could drop it in like this, right? Up and down, Yon. There you go again. Can that please? Two more. That's 2015, I think. These two is 2015. I don't know. Try to use my answer, right? For each one.
That's what we can say.
No.
No, because oh, we stop. What's going on? No, we can stop. That time? That's not. No.
The expansion for A cube. Okay, Shavel. Kabir. Shavel, what you saying, Kabir? Well, what are the expansions for A cube plus B cube and A cube minus B cube? What's the expansion here? A plus B by what? Plus, and what's the expansion here? Right? Some of you all getting the expansion wrong, right? Something I forgot to mention, right? Everybody watch here. Right? Something I forgot to mention, right? If you have the limit, right? As x approaches 0 of sine theta and theta. Sorry. Sine x over x. That value is what? That value is 1, right? But suppose Javed had x over sine x. What would it be? Right? So in short, it will be the same answer. It will be the same answer. Here's why. Here's why, right? When you have sine x on x, right? Technically, you are finding the limit as x approaches 0 of sine x over the limit as x approaches 0 of x. So if this is equal to 1, what does that mean? It means that the limit as x approaches 0 of sine x is the same as the limit as x approaches 0 of x. Correct? So these two things equal. So if I flip them over, it don't matter. I'm going to get the same thing. You're seeing that? Right? So let's make a note. I forgot to give it at the beginning, right? That's something interesting that you might recognize. Right? The reason I give it here, you might be able to use it here. Right? You might be able to use it here. Oh, yeah, go to all three. Anybody confused? Huh? Oh, yeah. Sorry about let's do all again. Right, I do number one. I do number one. Online audio, okay, right? The question, just double which one you want to do redo, right? So we get the limit as x approaches -2. Right, remember, 8 is like 2 cubed, right? So you'll get x squared minus 2x plus 4, right? All over x minus 2 x plus 2. The x plus 2 will cancel, and now we can plug in minus 2. Remember this is minus 2 squared, right? So that's 4 plus 4 is 8, that's 12. 12 1 minus 4 is minus. Here, what we can do first here? What we can do first here? Substitute our give it in determinant. What else we can do? You shall say factorize. Huh? Flip it. I can flip it just like factorize. So you'll get the limit as x approaches 0 of 2x by x plus 2. What can do now? Take up. Now you get some right to it. Just one. Not even the whole thing. That's half. Flip. I can't just flip and down. See that? I can't just flip it. And I have x plus 2 there. So what to do? Cancel it out. What? You just make something on this one, right? What else they can do? What else they can do? What else they can do? Huh? Separate it, right? So Page said to separate it. So it might look like this: 2x over sine 2x multiplied by the limit as x approaches 0 of x plus 2. What this is? 1. I'll show you why it's 1, right? It doesn't matter how it is, they will still get 1. And what this is? What this is here? Huh? That'll be 0 plus. So that'll be 1 by 2 as 2. Right? Could I have done it differently? Watch this here. If you're not seeing that, split their Javin. Darian, watch here and stop distracting them now. Right? So watch here. If you're not seeing that, here's what you could have also done. And you would have normally multiplied this by 2x on 2x. So this 2x comes underneath here. And this 2x will cancel here. And so you'll kind of work out that way as well, right? So you'll get 2 over 1, which is still 2. Okay? So that can sort of work as well. Chuck? So one option, Chuck, was to multiply underneath by 2x and 2x. The 2x underneath comes here. And this 2x will cancel with that 2x there. And then the limit of this is 1. The limit of this is 2. 2 on 1 is still 2. But I like this one more, right? Yeah. I'm multiplying it by 1. Right? I didn't want to put it, I could have put it outside here as well. But I didn't want to put it outside here and kind of confuse up. Put it right here. I could have also multiplied 2x and 2x outside. But I didn't want to confuse them. I like it inside. But I like this method more. Okay? And we just learned that 2x on sine 2x is the same as sine 2x on 2x. Last one. Take your time here. This one you might have to make up your own rule. Yeah.
Yeah.
Even now, try the last one. Let's see what's here.
Yeah.
Try to make it look a little bit simpler, right? Try to make it look a little bit simpler. Few lines long. Marion, I want to move on and take it long. Pick up. We're trying. Change. Okay, I didn't think that. Try to see what one. Whatever easier way, but try to see. I did one thing in maths. You can try a thing and see. So you got to place sine 2x with 2 sine x plus, right? Then you will factor it out. Then you will end up with problem. Have an easier way, right? Dylan, what you can do here with this x? Leave it there. Huh? Cancel here. But and these are the division, so it needs to divide in here and here. Separate it up. Right? Separate it up. Right? So separate it up and see what happens, right? Oh, I see. I was wrong on you, right? Right? Okay, I'm wrong, Peter. Right? What we end up with? Wait, okay, I'll wait. Right? Take your time, do overthink this one, right? This part's simple. Take your time when you plug in the zeros, see what will happen. Right. Vinesh, help out here. What to do here? Here is sine 2x on x. What to do? Multiply, no, but what you want here? You have 2 here because you have 2x here. Right, multiply by 2 on 2. Right, so the 2 will come here, the next 2 will come out here. So you'll end up with 2 by 1. What to do here? What's the first thing you can do? Cancel. And then what you can do, Sophia? If you plug in 0 in here, Yeah.
Right.
That's all. So you're going to get 3. Right? So you can learn that if you didn't recognize that. Right? This value is always 1. Get it? Yeah. Get it?
Which is right?
When we see how over there, they're like 2 on 2, and then you 2 cross on down, and then after come outside, sometimes it's, and like so many examples, you 2 will go in front each side, or something like that. But I just
Who will go in front of you?
sides.
Oh, it'll be one more step after that. So if I put it 2 here, then I will factor it out. Because it must be in this form here for it to be 1. Right? I did that in the beginning before I applied the rule. Now that it's very hang I just do it like that. All right, 5 minutes, then we continue, right?
Oh, okay.
5 minutes, and then we go in again. Online, take a 5 minutes, right? Yep, we're done. Let's go. All right, last one. This is 2021. Last one, are we done? And then we take a look at first principles. How to show that. Try this, please. 2021. 21 number 6.
Yeah. I think the mind
Are you done?
Yeah. And with no, it doesn't. What?
Last part. Next part there. Darian or Victoria.
Yeah.
And the last part is the secret continuous. Right? Secret continuous at x equals to 1. That's the last part. Hurry up. Hurry up, 2 minutes again. Let's start now. Alright, time up. Let's start. Javed, how do you show limit access? Javed, how do you show limit access? Right? So approach from the left. What function are we using? When you approach from the left. First one. Very good. When you plug in 1, you will get 5. What about when you approach 1 from the right? What function are you using? Right? Because of the more than, right? Well, there's a slight problem. It is indeterminate. You have to factorize and simplify. X minus 1, x plus 1 over x minus 1. $21. Right? So that will cancel, and when you plug in 1, you will get 2. Are they the same? Therefore, limit does not exist. And now they want you to determine if it's continuous. What is f of 1? What f of 1 Keshav? Look at the function. F of 1 is what? Look at when the function is defined. F of 1 is here. So f of 1 is 2. Right. But the limit doesn't exist, so we don't multiply, right? The limit doesn't exist. Yep, the limit doesn't exist and it's not the same. So therefore it is discontinuous. All right. Are you okay with that? Hey, also get jump. All right. So I wanted to show you one last thing before we wrap up. I'll do it again next week. It's something called first principles. Right, but I worry that the limit kind of slip out your head between now and next week. Right, I'm going to show you how to do first principles.
So we don't.
All right, one more thing I wanted to show you. I just want to introduce first principles today while you're right? So the differentiation that we doing in pure is the same as that one. Okay? Questions be a little bit different, but all the rules is the same. Right. All right, last thing, right? So how do we differentiate? How do we differentiate? What is here? How do we differentiate x squared? All here, what's here now, right? How do you differentiate x squared? 2x, right? We could also differentiate from something called first principles, right? You might remember that dy dx is the same as gradient, right? So here we could do, we could check the limits as h approaches 0 in this particular expression here. F of x plus h minus f of x all over, well, it will turn out to be h, right? All over x plus h minus x. You might recognize this as y2 minus y1 over x2 minus x1. Right? So we're technically checking to see how the gradient behaving. Okay? So how do we do first principles now? Real simple. All we have to do is apply limits to this function here. And f of x is what we have on top here. So if f of x is equal to x squared, right? I will end up with dy dx being equal to it'll be equal to, what do you think is f of x plus h if f of x is x squared? It'll be x plus h all squared minus f of x, which is x squared, all over x plus h minus x. You'll recognize that this always simplifies to h, right? So you will end up with, sorry, I left out the limit. So you will end up with the limits as h approaches 0 of x plus h squared minus x squared all over h. Whenever you're doing this and you expand the numerator properly, the x's generally cancel. Well, the x alone terms generally cancel out. So if I plug in 0 here, I'll get indeterminate. So I can't do it as yet. So I expand it on top. I'll get x squared plus 2xh plus h squared minus x squared. What happened on top? The x will cancel, right? So I'll get the limit as h approaches 0. I can factor out h, and I'll get h by 2x plus h all over h. What will happen now? H will cancel. And if I plug in 0, if I plug in x as 0, I'll get 2 by 0. Sorry about that. As h is the limit. Sorry. I'll get 2x plus 0. So the answer is 2x. Right? So the differential of x squared is 2x. Right? And this is called first principles. You only have to use this technique when the question says differentiate by first principles. Okay? You don't do it all the time. Only when they say by first principles. Are you okay with that? So you're using your limits to simplify it out. Just using one more since I don't mind. So next week I'll give you the list of rules for differentiation, and we'll do a couple of these, and then do some applications. Right, the only thing really new left for us to do is integration by substitution and differential equations. Right, that's the only thing that's new again. But we'll spend a lot of time on differential equations. What about this? Try one. Oh, they're good. Are they good? Okay, so for homework,
Yeah.
homework differentiators. Right? For homework, differentiators by first principles. Right? All right, copy it down. Copy it down.